Hey everybody, welcome back. This is part 2 of our dynamic routing video. We'll be going over the lab section. If you haven't already, I recommend going to the video description below and clicking that link so that you can download this for yourself. You can try and do it yourself before we go over it here, or you can just keep it for your notes and future reference and practice. So we'll hop into this lab here. The purpose is to configure the routers to use OSPF in order to connect all these networks. So going to our tasks, task number 1, configure in-use router ports with IP addresses that correspond with the networks they're in. Alright, so we'll go ahead and we'll start down here with router number 2. We'll go ahead and hop in here, skip the initial configuration, get into privilege exec mode and then global configuration mode. Now let's go ahead and start with G001. Which looks like that's going to be our port here in this red network. Of course, we got to put interface G001 if we want to go into the interface. And we'll give it an IP address of 30.30.30.1. Subnet mask is /24. Enter. No shut to bring that interface up. Let's hop into G002, which goes to our yellow network. We'll go ahead and give that an IP address of 40.40.40.1. /30 is 255.255.255.252. No shut. And lastly, let's hop into our green network interface, G000. Give that an IP address of 50.50.50.1. 255.255.255.252. And no shut. That should be good for router 2. Let's go ahead and hop into router 1 now. Get into global configuration mode. Start with that gray interface, G001. Give it an IP address of 10.10.10.1, 255.255.255.0. No shut. Next we'll hop into the yellow interface, G002. Give that an IP address of 40.40.40.2 because the other side had .1 with the subnet mask of a /30. No shut. Lastly, interface G000 for the orange network. We'll give that an IP address of 60.60.60.2, 255.255.255.252. No shut. Alright, that should be good for router number 1. Let's hop over here into router number 0 now. Global configuration mode. We'll start with G001 to our blue local network, given an IP address of 20.20.20.1 with a /24 subnet mask. No shut. Then we'll hop into our G000 interface for the orange network. IP add 60.60.60.1 because we gave the other router .2 with a /30 subnet mask. No shut. And finally, interface G002 to the green network, IP address of 50.50.50.2 because router 2 had that .1 with 255.255.255.252 and no shut. So from our diagram here, it looks like all of our interfaces are on and we have configured an IP address on each of those in-use ports on those routers. So I think we're good on task number 1. We hop into task 2, it says configure IPs on the computers that correspond with the networks they're in. We'll just start with PC 0. Go ahead and hop into the IP configuration. We'll give it 10.10.10.3, 255.255.255.0 for that /24. Give it the IP address of the router interface that's closest to us, our default gateway. Hop into PC 1. IP configuration, give it a 30.30.30.3. Oops. Try that one more time. 255.255.255.250 or 0, and its default gateway will be that router interface, which was 30.30.30.1. That should be good there. Final computer up here in the 20 network. Go ahead and give it 20.20.20.3 255.255.255.0, 20.20.20.1 for the default gateway. And we should be good. Moving on to task number 3. Ping within each individual network to ensure LAN connectivity. So if we ping our router here, 30.30.30.1, obviously issue the ping command first. We see we've got connectivity there to our router. Over here in the 10 network, let's ping our gateway. We've got connectivity there. And finally, up here in the 20 network, we have connectivity there. So we know that each local area network has connectivity between the computers and the routers. Next step, verify there's no connectivity between PCs in different networks. So if we start on PC 1, we should not be able to ping PC 0 in the gray network of 10.10.10.3. And our router's telling us, yep, I don't have a route to that route. Try and ping our computer up in the 20 network, 20.20.20.3. And likewise, our router is saying, hey, I don't know how to get there. Perfect. Next step, configure OSPF on each router to advertise the 3 networks that are directly connected to it. Go ahead and start over here with router 2. You can start with whichever one you like. But if we go ahead and do router OSPF, we'll just give the process number 1. For this, we will advertise the red network, because that's connected, which would be 30.30.30.0, 0.0.0.255 for a wildcard. And we'll just give everything in the network area 0. Go ahead and advertise the yellow network, that's also directly connected. We'll say area 0 as well. And then we'll advertise the green network. And that should be all we have to do for OSPF on router 2. Let's hop over to router number 1. Go ahead and start an OSPF process on there, router OSPF 1. Advertise our gray network, area 0. Advertise our orange network, 60.60.60.0, 0.0.0.3 for the wildcard, area 0. And advertise the yellow network, 40.40.40.0, 0.0.0.3, area 0. That should be all we have to do for router 1. Hop into router 0 now. Go ahead and advertise its 3 directly connected networks. Start our OSPF process, router OSPF 1. Advertise the blue network, 20.20.20.0, 0.0.0.255, area 0. Advertise the orange network, 60.60.60.0, 0.0.0.3, area 0. And finally, advertise the green network, 50.50.50.0, 0.0.0.3, area 0. Okay. And you see while we were issuing that final command, we started to get some neighbors coming up on the OSPF processes. Looks like we've got both of them come up now. So if we go show IP route, we can see in here now we know of our directly connected networks 20, 50, and 60, and we've learned through OSPF the 10 network, the 30 network, and the 40 network, and that is all the networks in the diagram. So now if we move on to step 6, verify that there is now connectivity between the networks. We should be able to go back to PC1, and now we should be able to ping the PC up in the blue network at 20.20.20.3, and we sure can, getting replies from there. And we should also be able to ping the PC in the 10 network, 10.10.10.3. And likewise, we can reach him. So it looks like we have successfully configured these routers to participate in the OSPF. They're advertising the networks that they can see, and that provided full connectivity to all of our devices here. I hope that this video was useful to you guys and that you got something out of it. I hope that you'll join us for the next video where we start to hop into VLANs and subdividing our subnets even further into logical separations just across switches. We'll see you in the next video.